Now let's see the reaction of acids. Now acids react with reactive metals to form metal salt and hydrogen gas. This is called the reactivity series. And this series is going to rank the metals in order of reactivity, where you have the most reactive on top and the least reactive at the bottom. And this reactivity series is going to tell you which metals will react with acids. So all of these, see, hydrogen here is going to act as a benchmark. Hydrogen is not a metal, but it's still found in the series because it acts like a benchmark. So everything that is above hydrogen is classified as being reactive, and whatever is below hydrogen is classified as unreactive. Okay, and potassium is the most reactive metal from that series, and gold is the least reactive from that series. And you can remember that series using any form of mnemonic. I use a simple one. That's what I use to remember it. So please send Charlie's monkeys and zebras in large hot cages, most securely guarded. This is what I use to remember the reactivity series, because this will not be provided to you in the exam. You need to remember it. So please is for potassium, sodium, sand, calcium, Charlie's, monkeys, magnesium, and aluminium, zebras, zinc, and iron. Large is for lead, hot is for hydrogen, cages is for copper, most is for mercury, securely is for silver, guarded is for gold. So please send Charlie's monkeys and zebras in large hot cages, most securely guarded. So the monkeys and the zebras need to be guarded properly. So this is what I use to remember this reactivity series. Now, from that series, we know that acid will react with reactive metals to give salt plus hydrogen, which means that the acid will react with anything which is above hydrogen. So all these are reactive metals to give salt and hydrogen, which means that anything which is below hydrogen will not react with acids. So make sure you note that copper, mercury, silver, and gold will not react with acid. Okay, so zinc plus hydrochloric acid. So the salt of hydrochloric acid is called chlorides. So you can have a little note. So hydrochloric acid forms chloride, sulfuric acid will form sulfate, nitric acid, nitrate, carbonic acid, carbonate, phosphoric acid, phosphate. So these are the name in which the salts end. So zinc plus hydrochloric acid is going to give you zinc chloride plus hydrogen gas. Iron plus sulfuric acid will give you iron sulfate plus hydrogen gas. Copper plus nitric acid, see that copper here is an unreactive metal. So copper is below hydrogen. So here there's just going to be no reaction. So you're just going to write no reaction over here. And magnesium plus carbonic acid forms carbonate. So you'll have magnesium carbonate plus hydrogen gas. So complete these word equations. Now here you have the chemical equations that you'll need to complete, and for each of these chemical equations you will have to first complete it, balance it, and write its ionic equation. So let's do for one. So sodium plus sulfuric acid, you will have sodium sulfate. So sodium sulfate, sodium has symbol Na, sulfate SO4, sodium valency 1, sulfate valency 2, cross multiply, sodium sulfate is Na2SO4. Right? So Na2SO4. And because it's metal plus acid, it's going to give you hydrogen gas. Hydrogen gas is H2. Remember, it is diatomic. So now I have the equation. I will need to balance it. Step 2 is in red. So 2Na, so 2 here, H2, so there's 2H, that's fine. SO4, there's one SO4 here, one SO4 here. So the equation is now balanced. We don't need to fill all the blank spaces over here. So this is balanced. Now I will need to write its ionic equation. Remember, whatever is solid, liquid, gas does not split. Whatever is aqueous will split. Third step is in blue. Solid does not split, so Na is solid. I have 2 of it. H2SO4, it is aqueous, it will split. H plus, there is 2 H plus. SO4 exists as SO4 2 minus ions. Na exists as Na plus, but there is 2 of it, so 2 Na plus. Plus SO4 is SO4 2 minus. Plus H2 gas, this does not split. So this is the same, so it cancels out. So I am left with 2Na solid plus 2H plus, giving 2Na plus H2 gas. Include state symbols, aqueous, and solid. So this is the ionic equation for this chemical equation. You're going to complete for this and this one as well. Okay. Now here you have an experiment. We're going to do this experiment when we meet again, and we're going to complete this as well. Now note that lead does not actually, if you look in the reactivity series, you will see that lead is above hydrogen. Normally lead should react with acid, and it does start to react, but as soon as it reacts, a layer of, if you're reacting with hydrochloric and sulfuric acid, a layer of lead chloride or lead sulfate, depending on which acid you're using. So if you're using hydrochloric acid, you have a layer of lead chloride. So let's say this is the lead that you're putting in the acid. So you're putting HCl. You have a layer of lead chloride that starts to form all around that lead. Now that lead chloride, PbCl2, is going to protect the lead inside and prevent any further reaction. So that layer is insoluble and forms a coating which protects it from any further reaction with the acid. So this is why we will say that lead does not react with hydrochloric acid or with sulfuric acid. It will not react because an insoluble layer forms around that metal that prevents any further reaction. Second thing important is that acidic foods are packed in aluminium containers, and aluminium is normally a reactive metal, but it will not react with acid because it is covered with a protective layer of aluminium oxide, which means that when you have aluminium cans, all the aluminium that is exposed to air is coated with a layer of aluminium oxide. So in the air you have oxygen. So oxygen reacts with aluminium. So O2 plus aluminium will give you aluminium oxide. Right? You balance the equation here. So the aluminium oxide is going to act as a protective layer to that aluminium and prevent any acid in the food. So let's say you have put tomatoes in that can. So the acid in that canned tomatoes will not react with the aluminium can because of that layer of aluminium oxide that protects it. So write a balanced chemical equation for the reaction between aluminium and oxygen. So this is the equation. So make sure you write that down.